to keep straight. We got to know that zeros come from the top of a rational function, that discontinuities are in the bottom, how to find a hole, how to find a vertical asymptote, when we need to look for a slant asymptote, all of these different types of things that we need to know. So it just goes over a few things here. They're not really wanting you to write anything. It's just reminding you, if you are seeing left end behavior, then your x approaches negative infinity is the limit that you're looking at. Right end behavior, x approaches positive infinity for this. If we're doing end behavior, what was it for rational functions that we used? There was like a phrase. Oh, sorry. There was a phrase there. For end behavior, or limit set of infinity, or horizontal asymptotes. Is no ECC. So this is where you're going to use, let's see. Let's see if it'll just let me do this. Choose a different color. Highlight it. Let's make it come up. Okay, and remember that no ECC. We're talking bigger on the bottom. The degree is bigger on the bottom. You'll get 0. Bigger on top, not 1. Now you got to do some division to decide if it's positive or negative infinity. Eats DC. Exponents are the same. Divide coefficients. This is what you're looking at for end behavior of a graph. Okay. If you see the phrase as the input values decrease without bound, then that's your limit as x approaches negative infinity. If you see as the input values increase without bound, that is positive infinity. That's the right side. So if we look at these two examples that they have given us here, for the graph of f here, let's see, Mason, what is our limit as x approaches negative infinity? Nope. Think about what the y coordinate is doing. Nope. It is going up, but does it go up forever? F right here. Yeah, that first graph. So if you start somewhere in the middle and you go towards the left side, it's approaching 1. Very good. So you get 1 for that. Because while it does go up, it's not like going up forever, right? It's being bound by that horizontal asymptote in that case. What about on the right side, Mason? Also approaching 1. And that's what you'll usually see. They're usually the same from both sides.
How do you know where to start on this graph?
Whenever you are looking at limits as x approaches negative infinity or positive infinity, you are only looking at the ends of the graph, what is happening as you go towards the ends. So anywhere in the middle of the graph, you can start, you're going towards the left side of the graph, towards the end of the graph, where the x values are getting bigger and bigger and bigger and bigger, but more negative. There. And then over here, for x approaches positive infinity, you're looking at the end of the graph. So you're looking at what's happening on that right side of the graph. So when we go to, oh, sorry, they were both called F, so my F was not helpful there. Reese, if I look at the second graph that we've got here, what is my limit as x approaches negative infinity? That would be negative infinity, because on this side, there is a slant asymptote, but this just keeps going down forever, right? It's going to be like sort of bound by that line, but that line goes down forever, so it's still going to be negative infinity. What will we get on the right side of that graph? Positive infinity. It is a slant asymptote. Your end behavior is still just positive or negative. If you have a slant asymptote, your end behavior has to be positive or negative infinity. Because think about slant asymptotes, how we do them algebraically. You've got the numerator is 1 bigger than the denominator, so if it's bigger on top, you're going to get positive or negative infinity. Okay, really important here, if the graph has a horizontal asymptote, the y value of the horizontal asymptote is the limit. So horizontal asymptotes, limits at infinity, are going to be the same. So if I look at the limit as x approaches really positive or negative infinity of f here, okay, I will get 2/5. Because for this one, my exponents are the same, so I will divide coefficients. It does not really matter whether it is positive or negative infinity. You will get the same result whenever you have an exponent to the same situation. Okay, Chandler, how about the g of x there? If I've got 3x squared plus 5 over x to the third plus 2x minus 9. That one's 0. And it will be on both sides. You'll get a 0 for that automatically because your degree is bigger on the bottom. Okay, those two are the quicker ones to find. They've given us the ones that are a little more difficult here in the next box. So if your degree is bigger on the top, then this is you're definitely getting positive or negative infinity as the answer. But to find out if it's positive or negative infinity, what do we have to do? We're going to divide the highest degree. So we're looking here at my x to the third and my 2x squared, and it's doing some crazy stuff there. I don't know why. And so when I divide those, I will get 1/2 x. And then I want to think about what the end behavior of that graph would do. It does not mean it's the same graph as this, but it's going to have the same end behavior as this. So since my coefficient is positive, I will get a positive infinity for my right statement. And then what will I have for my left statement? That one will be negative. Degree is odd. Right there. Because it is a degree of 1. So the opposite side will do the opposite thing. So if I do that same thing over here, I've got negative 3x to the 5th and x to the third are my highest degree terms. If I divide those, I'm going to get negative 3x squared. It's not going to be exactly the same as this graph, but it's going to have the same end behavior as that graph. So the right side will be negative infinity, and the left side will also be negative infinity because you have an even degree. Yeah, they'll be on there. You'll be asked to expand something using Pascal's triangle. It will not just like ask you for it, but you'll need to be able to come up with it. Okay. Questions on that first stuff with your limits and end behavior? Yes. Okay. Let's see. Do I have it on here? He didn't put that on here. What is your question on that? It could end up in either spot. There. It could end up on either one.
So for like this part with the limits and behavior, so like on the equation, you just pretty much divide the coefficients or just see what the degree is and then figure out what to do from there. And then on the graph, you just see where it lies.
Yes. Yeah. Okay. So let's move on to a couple other things. limits and vertical asymptotes. It is really easy to get these mixed up whenever they start giving you limit notation again, but it does not approach infinity or negative infinity. Infinity and negative infinity is your end behavior. It's bo, bo, bot, no, eat, cc. That's what you're going to use. If you see limit as x approaches 2 or any other number right there, you're not talking about end behavior. You're either talking about limits at vertical asymptotes or holes. It's more likely that it's a vertical asymptote, but it could be a hole as well. So, whenever we look at this right here, I've got x approaches 2. What's the little negative behind it mean? From the left. So you are thinking about where x equals 2. X equals 2 right here. And you're thinking about that vertical line that goes through 2. So if you approach that line from the left side. So I'm going to start over here on the left, and I'm going to get closer and closer and closer to that line. What are my y values doing? They're going up to positive infinity. And it slid down for some odd reason. Okay. How about whenever we have the little plus sign behind? From the right. So I'm approaching from the right. What are happening to my y values? They are decreasing, which is going to give me negative infinity. And that is sliding those answers down there, but the top one is infinity, bottom one is negative infinity. So be really careful with those. Whenever you see that number, just because it's limit, you might start to look at the ends of the graph. That is not what it's asking for here. It is usually at a vertical asymptote. Okay, let's say that a question like this shows up on the calculator inactive section of the test. So if it's calculator active, you could graph it and look at it. But if it's not calculator active, and I look at this graph and it's asking me about the limit at 1, what do I have happening at 1? I've got a vertical asymptote because that's going to give me a 0 in the bottom, and it doesn't cancel out with the top, right? So I've got a vertical asymptote at 1. So what we need to do for these is we need to decide if it's positive or negative on the left side or the right side of 1. So you can make yourself a sign chart for this. So you would need to include everything. So you'd have -2. You would have x minus 3. You would have x plus 4. And you'd have x minus 1 squared.
Why do you need a -2?
Because it's going to change the sign. So it doesn't give you a 0, but it does change the sign of everything because it's negative. So you always want to include everything over here on the side. This does not give you a 0, so it doesn't go down here on the number line. So you wouldn't put a -2 or a +2. It doesn't give you a 0, but you do want to include it. I guess I need an answer line.
So like,
here.
How would you like put the values that you get down here? You just put that in.
You're going to use the zeros, so that would be +3, -4, and +1. So I'll put -4 here, 1 here, and 3 here, and then let's see if I can make my chart here. So -2 is negative all the way across.
Oh, so you don't
Yeah. But it does affect your answer. If you leave it out, you'll get the opposite of the correct answer. And then if it's a positive number, technically you could leave it off because the positive's not going to change anything. But best practice is to always put it there so you don't mess up when it is negative. So here we'll get negatives up into the 3, and then we'll get a positive here, here. We'll get a negative for that first one, and then positives here. What will we get on our x minus 1 squared line? That's going to be positives all the way across, because when we square something, it makes it positive. Make sure when you put that one on there, it has to include the square for that. So we would get a negative here, a positive here. We'll get a positive here as well. Put that right down. And a negative here. The only thing we really care about this one, because they asked us about 1 right here, the only thing you really care about is what's happening right here at 1 on the left side and the right side. So other parts of the graph we really don't care about because they didn't ask us about those. So we would get positive infinity for both of these answers, since both of those are positives. Okay, questions on that? Okay. At a whole, you might see some limit notation at a whole. Remember that limits are asking you for what the y value is doing. I don't like the example that he gave here, because what is our y value at our whole here? 2. I don't like that it's 2 because you're also approaching 2 on the x-axis. I wish you'd made it a different number just so it was very clear that those are not always the same. But this is 2 because you're going to that hole and you're looking at the y value. So from the left and from the right, your y value approaches 2. Yeah, at 2, your y values get closer and closer and closer to 2. Now, for this problem, you have a vertical asymptote. If they had asked you about 1, you would have different answers. But they are asking about as x approaches 2, which is where the hole is. Correct. You should get a number at a hole. The only time you will get positive or negative infinity is at a vertical asymptote. So if they had asked us about 1, then on the left we would get negative infinity. On the right we would get positive infinity. But they asked us at where x equals 2, and right here at x equals 2, that's where you've got the hole. So be really careful at where you're looking at. The most important part of the limit that you're going to look at is what number you're approaching. So positive and negative infinity, that's in behavior. Then if it is a number, you're going to where x equals that value, look up or down. A lot of times it is a vertical asymptote. If it's not, it's probably a hole that they're asking you about. There.
Wait, so if it was asking about 1, what would it be?
From the left, it would be negative infinity. From the right, it would be positive infinity. Correct. Yeah. Because they're only asking what's happening close to 1. So, although there is a hole here, as you get close to 1, you're still just going up. Yeah. Okay, let's do a hole from the equation. So, let's say they ask us without a graph and without a calculator. This is a little bit like that last part of that FRQ that we just looked at. If they are asking us a limit at a hole, so you can see right here that these 2 right here would cancel, and I would have a hole at x equals 3. And they're asking me about 3. So if I plug 3 into the equation itself, I will get 0 over 0. But if I have canceled these, then I can plug 3 into what is left. So if I do 3 plus 5 over 3 minus 1, I will get 8 over 2, which gives me 4. And at wholes, it does not really matter whether you're approaching from the left or the right. For equations like this, you would get the same thing over here. The same way. Okay. Questions about anything there? You know what wasn't on here I should have added? I just went with what Mr. Passwater had. Let's really quickly, zeros. Let me type it. Let's add this at the end. I'm going to type it because I can't. Why is it doing that? Let me try now. Okay, so zeros of rational functions. All right. Where do we have how do we find zeros of rational functions? Okay. Values that make the numerator equal to 0. That are not wholes, so they can't cancel with the denominator. So, let me give you an example here. Alright, so for example, what are the zeros of this equation? Okay, so for this one, I need to be looking at the numerator. I should get, we'll do the easiest ones first. Alright, why is it not letting me write? So I should get x equals -5. Theoretically, I should get x equals 2. Although we got something coming here in a second. And then I should get x equals, right here, what will I get for the 2x minus 3? I will get 3 halves because I will have to set 2x minus 3 equal to 0. So 2x minus 3 equal to 0. I'll move the 3 over to x will equal 3. And I'll divide by my 2. So, theoretically I should have those, but one of those is not right. What do you think, Michaela?
The one that's not right is the x minus 2, but I had a question about 2x minus 3. Can you put it in the decimal?
Yes, it'll be fine. If you do 1.5, it'll be okay. It is more likely to be a fraction if it's a multiple choice question, but it's okay as long as they're equivalent. So why did you say 2 is not it?
Because when you factor out the bottom,
Good.
you get x minus 2 as one of the factors, and so it cancels out with the top.
So you got an x minus 2 times x minus 1 right there. So that x minus 2 is going to cancel on top and bottom, meaning what do you have there? A hole in the graph. So that cannot actually be a 0 because you have a hole in the graph. So you would just have -5 and 3/2 for that. So be careful with holes. All right, I am going to go over to AP Classroom now, and now might be a good time for you to make sure you're pulling up those multiple choice questions to see which ones you missed. I want to look first at the ones that were most commonly missed among the class. There are a few of them we're not going to spend a great deal of time on because I don't personally love them anyway, and you're not likely to see the same thing on the exam. So, let me cut this off for a second until I get to the right page. Let's see. This one thing. I need to go here. Results, that's what I need. I'm going to go to questions. Okay. Alright, so let's look and see how we're doing here. Really, we're not doing too awfully bad till we get down here. So let's look at 10. I mean, not the one that 10 missed, number 16. Okay, so for this problem, it asks you for, it gives you the domain, it gives you h of x equals 3g of x over 2, and asks for the domain of h. So this function has two things that have happened to it. Let's see. Kendall, what's that 3 out front do? If we multiply a function by 3, it's a transformation. What does it do? Okay, what do you think, Connor? Vertical dilation by a factor of 3. It stretches it up by a factor of 3. Does that affect the x values? That affects y values. So that 3 actually does not do anything to our function, really. The g of x over 2, this is where the x values are going to be affected. Now that x over 2 might be a little bit confusing to you because we didn't really talk about dividing by 2, really. We talked about multiplying by a number. We were multiplying. But whenever you have x over 2, it is the same as 1/2 times x. Okay, so that's the way you really want to think about it. So for that, if I multiply by 1/2, so Marley, if I multiply on the inside by 1/2, what is that going to do to my equation? It's going to be like wider, or it's going to be called a horizontal dilation. What factor would it be? It's going to be 2, not 1/2, because everything's backwards, right? It flips it. So it is a horizontal dilation by a factor of 2. It's making everything like twice as wide. That will affect our x, which is our domain. So you're going to multiply by 2, and that gives you the correct answer there. Yes. The only time it would not be is if like you had 2x over 3, something like that. Then it would be like 2/3 times x, so you'd flip it, it'd be 3/2 for that. But yes, if it's divided lot of you picked this one. I think you guys probably like use the 3 there instead. A few of you picked this one. You just straight multiplied by 1/2. But you got to remember the factors flipped whenever you're on the inside of that equation there. Okay, does that help on that one? Let's go back. So we did not do well on this one. I don't like this one anyway. Your correct answer is piecewise linear. I think I even maybe led some of you to believe it should be quadratic because it does have it. The reason it's not is because this applies for a domain instead of a certain number, and this is already a rate. And they're asking you about C. I don't like that one. We're not going to do.
What is
I'm not
it?
going to do that one.
What is it?
Quartic would be to the 4th power. 4th power. I'm going to go over these that we missed most first, and then if we have time, we'll look at them. A linear function is just a straight line, like this. Piecewise linear could be different pieces of lines put together. So, like, what would happen on the one we're just looking at? It would have a slope of 40 at first, and then 39, and then 36. Like, it'd be less steep. You'd have, like, these segments that are different. But that one's not my favorite question, so we're not going to spend much time. Let's see here. They ask us which of the following input values corresponds to a hole in the graph of R. They have worded it a little bit differently maybe than we sometimes see, but it's just asking you where the hole is at. So what you should do for this problem right here is you have x to the 4th minus x squared. You should factor out an x squared in the top right there, which will leave you x squared minus 1. And then in the bottom, you will factor out a single x, and then you will have x squared minus 2x plus 1. There. And then this will factor further, so you'll have x squared, and then you'll have an x plus 1, x minus 1 here. And then in the bottom, you're going to get x minus 1 times x minus 1. And then you'll still have an x right here. So, like, one set of x minus 1s does cancel. Do you have a hole there? You do not. Why do you not have a hole at x equals 1? Because you still have a vertical asymptote there. That vertical asymptote is left. So you have a vertical asymptote at 1, not a hole for that. Because a lot of us picked 0 and 1. Or this. You cannot have a vertical asymptote and a hole at the same place. So if you have a vertical asymptote, it like overtakes the hole and you don't have a hole there anymore. But here, you would have one of these x's would cancel with one of these x's in the top. That is going to be a hole at x equals 0. You do have something left, but it's in the top, not the bottom. So x equals 0 is your answer for that one. Questions on that? All right, let's look and see. 21, we did not do very well with. Okay, so it gives you graphs of f and g. Which of the following defines g in terms of f? So you are starting with f, and you need to end up with g. So first of all, I noticed that f is much, or g is much taller, right? It's been stretched out vertically. How do I stretch something out vertically? Okay, outside of the parentheses. Now, problem is, they gave me some different options here, right? One thing I can kind of do is look at the endpoints and sort of see what happened here. That endpoint's not all that helpful because it's on 0, and when you stretch something on 0, it doesn't move. This one right here, not the most helpful because it's not on grid lines perfectly. This could be helpful, but it also might be shifted up or down. So this was 2, it went to 5, which might lead you to believe that it's 5 halves. But has this been slid up or down any at all? The key for knowing this is this point right here. When you stretch this out, it's not going to move because that graph is on the x-axis. But over here, it's not on the x-axis anymore, it's down, right? So this has been moved down 1. So that is going to mean that it's going to be C or D. Notice both of these have 3, so I don't really have to worry about that a whole lot anymore. This has also been squished in because the furthest, like your domain here is -2 up to 4, but your domain here is just -1 to 2. So it's also been squished this way. Remember, everything on the inside is backwards, so to squish it, like to make it half as wide, you have to multiply by 2, not the 1/2 right here. So it's going to be this one right here for that. Points on the x-axis or the y-axis really help you see if things have been moved up, down, left, or right. And then your domain and range can really help you on that, whether it's been like shifted or whether it's been not reflected, dilated. Okay. Let's see. Those are all the ones that we missed pretty badly. Reese, which one did you have a question about? Okay. For 8. Okay, so it tells you that you have a function where n and d are polynomials. So we don't know what they are, but they are polynomials. The degree of n is less than the degree of d, which means that if n is less than d, then this is bigger on the bottom. And whenever a function is bigger on the bottom, what do we know about its end behavior? Its horizontal asymptote, or its limit as x approaches positive or negative infinity, it's 0, right? So what you're looking at on this graph is you're looking for, on the ends of the graph, this graph needs to go to 0. So like right here, this one's going down, this one's going up, that's not it. This one is going up, up, that's not it. This one looks like it has a horizontal asymptote, probably, but is it at 0? It is not. D, right here, this gets closer and closer to 0, as does the other side. So that one's going to be your answer for that one. All right. And the last one here. Okay, let's see. Okay, so this one, here, they give you this form where you got like this R1, R2, R3, R4. These are your zeros of the function. They tell you that you have 2 real zeros at -1, 0, and 2, 0. And they also tell you they each have a multiplicity of 2, right? So if that is the case, then that means you're going to have like x plus 1, x plus 1, x minus 2, x minus 2. That gives you all of your R1 and R2 values right there. So you can definitely find all of the R1, R2 values there. Then they also give you the y-intercept for that. So in this case, what we're looking at is we've got give me more space. Let's do that. Oh, there we go. Okay. So we have got, we know we will have x minus 1 squared and x, if I got that right, or is it plus? It is plus. And then x plus 1 squared and x minus 2 squared. And then we got just y, or f, equals a times that. So we can find that part of the graph. They also gave us the y-intercept, which is 0, 24. So it's asking if I can find a pretty much now. And I could, because if I take these coordinates and plug it in, I could put 24 right here. And then a would still be there, but I would have 0 plus 1 squared and 0 minus 2 squared, like that. And so 24 would equal a, and this is just going to be 1 right here, and this is going to be negative 2 squared, which is 4. So that's 24 equals 4a, and then you would divide both sides by 4, and so 6 would be your a value there. You plug it in because in this point right here, x is 0 and y is 24. So it doesn't ask you to find it. You just need to know that it's possible. Yeah. So you don't actually have to find 6 there, but it's just asking if it could be found. If they gave you this information and did not give you the y-intercept, you could find all the zeros there, but you could not find a, right? Or they could give you another point on the graph. They could give you like the point 216 or something, and then you could still find a, although probably not by hand very easily if they gave you that point for that. Okay, other ones, questions anybody else has? Yep. Let's see. 22. Oh, this, you won't see this on the test. I should have went over it, though, in case you might see it on the AP exam or something. One thing the answer to this is the cubic. The reason that it's cubic has nothing to do with the data, except for there's only 4 points. I did not run through this, so you might want to pay attention right now. You kind of already know a little bit of this. If you have 2 points, what kind of graph can you definitely put through any 2 points, no matter where they are? I can make a line, no matter where my 2 points are at, right? I can put a straight line through those. So if I have 2 points, a first degree function will go through those points. Okay? Now we haven't talked about this, but if I put any 3 points anywhere, okay, I can make a quadratic that will go through any 3 points. No matter where you put them, it might not be, that's a very ugly quadratic, it might not be like the minimum or something like that, but you can, any 3 points, you can put a quadratic. So if I have 3 points, I can always get a second degree function, a quadratic, to go through it. So this problem gave us 4 points. If you have only 4 points, then a cubic will always fit perfect. You can always get a cubic to fit perfectly for that. This is a constant. This is just like a horizontal line. The only time that would work is if all the values were the same. So that one would pretty much only work if you just had like 17, 17, 17, 17 on that bottom line for that. So
You said that won't be on the test though?
no, but that is why, in case that were to show up on the AP exam. Because this was not a calculator active question. Now, if you used your calculator because you didn't realize it was not calculator active, you saw the R squared value was 1. So it's a problem that like you could do with the calculator, given what I've taught you, if it was calculator active, but I haven't for that. All right. Any other last minute questions? 13. All right, this one is not scroll. Oh, there we go. All right, this one, the graph of the rational function r is shown with this hole at this point, which is the statement is true. Notice first of all your limits are at 1 and negative, or at 1 from the left and from the right. So you are looking at that place where you have a hole, right? At a limit, you are looking at the y value, what the y value is approaching. And so at this case, it's not defined, but the limits are still defined, because the limit isn't the value of the function. The limit is what you're getting closer to, right? So in this case, it is defined here, and it's going to equal 1/2. So it's going to be the y coordinates you're approaching there. Okay? And that is about all we have time for today. I do have Smart Breakfast in the morning if you have any questions, further questions. You do not have any assignments that you have to do that are due tomorrow. Just look over different stuff, study for the